Thanks very much for having us. It's a pleasure to be here. I didn't know that I would be sitting next to and following one of our customers. Focus on the customers. We're going to get some feedback. I know it. Feedback is a gift. Thank you. At GE, we power a third of the world's electricity, including our customers at Duke Energy. We take very seriously and are very proud that we fly about half of the world's passengers around the world. And we also work in a number of regulated industries, not just power and aviation, but also in healthcare. And that's where Sudhir and I met 13 years ago working together. That's right. We've parted ways and have worked in a few other GE businesses, but now we're back together again, working at GE Global Research. So we thought we'd share with you some of our stories around work together in a 125-year-old company that builds large pieces of machinery that go generally up and down and round and round. So with that, here's Sudhir.
Thank you, Lars. So as Lars mentioned already, we are a 125-year-old company started by Thomas Edison. And we are now transforming ourselves to become a lean startup. And, that's a fact. We have a lot of physical assets. I mean, we are in the infrastructure business, aviation, power, transportation, healthcare, oil and gas, name the infrastructure segment, and we operate there. All these assets are addressable, networked, connected, and as a result, we have tons of data that we are sitting on. And our digital strategy is about monetizing these assets. We can unlock a lot of keen insights, not only for GE, but also for our customers by using the data effectively and enhancing the life of the assets, improving the service productivity, the maintenance schedules of a lot of our assets. So what we're going to do today is talk about how we are going about our digital strategy. The vehicle that we are using to transform some of our businesses is Agile and agility, being agile. And we'll take two examples and talk you through the two industries where we deployed Agile. Both of us came from healthcare, heavily regulated industry. For 7 years, we were neck deep in the transformational journey with Agile in healthcare. And based on that experience, we went on to parlay those skills elsewhere within the different business segments. So I went to oil and gas and was in the subsea control space, and Lars is pioneering Agile in the additive manufacturing space. So before let me just give you a brief introduction. So oil and gas subsea controls is about a $4 billion subsegment within the oil and gas space, which is about a $16.5 billion segment within GE. So what I'm going to show you is a teaser video that introduces basically the subsea landscape for you.
Work on her, be blessed to bring prosperity to Ghana.
So what you saw there was a floating platform, it's called an FPSO, a floating product storage and offloading platform, where the oil or gas products that are pumped from subsea are stored for offtake by oil tankers. Now, that's a level of complexity above the surface, and there's a whole slew of complexity subsurface going all the way down to about 10,000 feet. And we operate in this space. So if you look at the technology stack that we deploy, there's electronics all over the subsea floor. And we design our own hardware, we design our own operating systems, tailored operating systems, real-time operating systems. We design our own modems, long offset modems that span 30, 40 kilometers subsea. So there's a whole slew of complexity that monitors and controls production of oil and gas. And a spoiler alert, the video that you saw earlier, we used Agile on that project. So let me describe the journey. Before I moved from healthcare to oil and gas, there was a typical courtship dance that you do with your hiring manager in the business. So during that phase, I was told, I was laid out all the problems with the Subsea software team. The problem space is very large. The projects are typically, a typical Subsea project is about anywhere between $120 million to about $1.4 billion, depending on the size of the oil field, between 1 or 2 wells to 20 or 21 wells. All these projects are fixed scope, fixed price, and fixed resources projects. So it's an iron triangle, a very difficult problem space to deploy Agile in. And software typically came in the critical path in every single project. The hardware, the hydromechanical systems, the electrical, the hardware stuff all came before, but software was always in the critical path, the central nervous system, the whole effort. So and it always contributed to delays. There were some projects that ran 10 years, some projects 2 years, but software always was in the critical path and contributed to delays of many, many years on some projects. One of the largest gas lift projects in the world took 10 to 12 years to complete, and software took 3 years to finish. So with that in mind, the charter was to somehow transform the software space. My hiring manager said, we need to bring in some of the software best practices, refresh the technology, and refresh the overall software engineering team. Morale was low because they were always beaten up because of the projects being late. And the typical state of being in the subsea domain, because these are fixed scope, fixed price, requisition projects, was that the interactions with the customer was always adversarial. So we needed to break that vicious cycle. So that was the state before Agile. And after I moved into the business, studied the business, we didn't go Agile from day one, inspect and adapt. That was the motto. So we didn't just take Agile from healthcare and overlay it in oil and gas. That would have been disastrous. So we studied what the problem space was, tried to understand the deeper issues before we started rolling out Agile in bits and pieces. But essentially, as we started gaining some momentum, we deployed Agile mainly as a continuous learning and a continuous improvement engine. We wanted to fail fast, learn from the problems, fix the problems, and move on. And we also used Agile as an execution engine, because typically in software, in the subsea space, you had no clear visibility on the quality of the product or the progress of the project, because they were long year, many year projects. So in order to get Agile going, we coached the entire team around the organization. So that took a significant effort, coached the leadership team, and most importantly, I'll pick on one story where we spent a lot of time, and that is in creating a specialized DevOps environment for the physical space. And this is what our DevOps environment looks like, because we focused on developing and testing our user stories in vertical slivers. We interfaced with a lot of equipment which are extremely expensive. These equipment run from $100,000 to about tens of millions of dollars, and you couldn't afford to buy these equipment for your testing. So we had to get simulators from our vendors and basically work with the vendors and the supply chain to make sure that we had advance warning of the firmware versions they were using so that we could interface with the simulators and test and validate our stories. The main problem invariably in the subsea space is interfacing with multi-phase flow meters, which is a special device that basically measures the amount of product that's flowing through the pipelines. And this used to contribute to many, many years of delays. But once we went Agile, so with these simulators, we were able to interface with all these devices that were going to be deployed Subsea to de-risk the project. We had lots of customer touch points and demos along the way, so Agile helped in many respects there. As an execution engine, you can see the velocity charts. We provided transparency, but this also caused us a lot of problems because every time we put up this velocity chart, I used to be hauled into the principal's office, and I was in detention, had to explain what we were doing. But the team used this effectively as a feedback mechanism and brainstormed on improvement ideas. So we were projecting delays. We were delayed on a lot of our internal milestones. But what was the outcome at the end of the day? We delivered on first oil milestone, which is a key revenue milestone because we have vendors that sink billions and billions of dollars in investment before even the first dollar is realized in revenue. So we did not compromise on the ultimate goal. Agile had great grassroots level acceptance. And importantly, that multi-phase flow meter I mentioned, we de-risked the entire project because at the end of the cycle, when you go into testing with the customer, that would have posed delays historically. We de-risked that by over 6 months. Quality was improved, and you have the metrics. Along the way, we lost a lot of minor battles, but at the end of the day, we won the war with first oil. So that's the story in a nutshell. I'll hand it off to Lars for his story on additive.
So when we think about additive manufacturing for GE, it's a lot of metal and steel and alloys, large, heavy parts. In many cases today, these are subtractively manufactured, which means you're milling and drilling and taking material away from a large piece of metal or steel. Additive manufacturing is essentially the opposite of that, where we take metal powder and we build up layer by layer using lasers or electron beam the part. That gives us great flexibility from a design perspective because now for our 9,000 design engineers in the company, they have incredible ranges of freedom by which they can design like they've never been able to before because you're able to build this part up out of a powder. What you see there is a fuel nozzle for one of our aircraft engines. And before I dig in a little bit deeper on how we bring Agile into this space, I just wanted to show you a short clip of a video. This video, you're going to see stuff that looks like snow. It's not snow. It's metal powder. And you see a couple of these images change. And those are basically different layers that we can build up in additive manufacturing. In one case, for transportation with locomotives, we reduced 200 individually casted parts down into one design part, 200 to 1, 25% stronger with 50% less weight. And that does amazing things for our customers.
In every generation, there's a moment where everything changes. A breakthrough that ushers in a new way of doing things and ensures the world will never be the same again. This is one of those moments. Introducing GE Additive, a new business that represents GE's passion for the industry and its tremendous potential. Its capacity to make complex parts that were once impossible to produce, to speed up the manufacturing process, and open up a whole new world of design possibilities. At GE Additive, we're leveraging digital industrial capabilities and new technologies to accelerate innovations across industries. From aerospace, power, and automotive, to medical, architectural, and consumer applications. And as a leading user of additive parts, we're committed to delivering world-class machines, materials, and services for customers around the globe. And once again, expanding the boundaries of what's possible.
So in the company, we're lucky to have 400 to 500 different manufacturing facilities around the world. Some of them are very nearby, and some of them are in far distant places like Pune, India, where we manufacture multiple parts for multiple businesses, assembly, fabrication, et cetera. GE is a user of additive. We are a manufacturer of additive parts. And because we've tested and learned and iterated on ourselves, we're also being able to sell these machines and some of these digital capabilities externally. One of the things we're learning is by moving and testing and de-risking up front, that has a lot of need for compute. So digital is becoming ever more important for us. And that's where we are being asked on the digital or on the software side. There's maybe 14,000 digital folks at GE of 280, 300,000 people in the company. So we're the minority, but we're being asked to drive speed and change and customer response faster. Here you see a number of the technical engineering disciplines on the physical side we get to work with every day. This is just an example. These are hardcore design engineers. These are folks that have PhDs in thermodynamics, materials physics. They love 6 to 12-month design cycles. So take a look at my two friends, Vrinda and Tyler. You guys can guess what Vrinda's degree is, I bet. Any guesses? She has a PhD, yes. She's also computer engineering. Tyler has a thermodynamics degree. Tyler is one of our best thermodynamic modelers at GRC. These are not exact quotes, but you can see there's a little bit of an adoption curve there. And as we talk about coaches and champions, one of the things we've found is Vrinda's really good at asking, why not? Why couldn't we swing at this, Tyler? Let's break your 6 to 12-month design cycle. What can we test and iterate in a couple weeks? All right, you don't want to meet every day. How about every other day? Let's meet in the middle. The hilarious thing was when they talked about retrospectives, Tyler was not interested in retrospectives. And he's one of the biggest champions, and he actually raises his hand now and says, we forgot to do the retro guys, right? So he's now a driver, and he's a champion with some of the other folks. We didn't put some of the chemical engineers up there. They're some of our hardest nuts to crack. But we love them. Additive is a space where just you can't do it by yourself. You're not going to win by yourself. Your discipline, your team, you got to do it together. Two areas where we try to accelerate and go really fast in research is, in one case, we're working with a manufacturing plant. We had about 20 different design options to help them, in some ways, Lisa, what you guys were talking about, get the work visible. So we queued up a nice big backlog. We put 30 people on it. We gave them a day, and we said, you're going to iterate 3 times with Terre Haute, Indiana, today. Got them T-shirts, ton of caffeine, good food. We got down to 3 design principles in a day in that case. In another case, we had about 12 to 15 different design possibilities and did a lot of backlog grooming to queue that up. Got the right people in the right big open room, and we were able to de-risk and identify 11 of those were not going to work for a number of technical feasibility reasons. We identified 2 in a day. We call that Flashworks, but anybody could try this. One of the things we're working really hard to do now is to scale these individual research teams and to start to weave and stitch them together so that in the end we don't have answers yes or no or maybe with different disciplines. We actually have an answer for the broader business or for their customers. That's a little bit more challenging for us to do, and those are some of the things that we're working on. Just because the nature of some of that work and those projects do have some very specific technical challenges in certain disciplines. But one of the great learnings we had was, for us, we have a lot of variety in our engineers, but engineers love to solve problems. Engineers love to troubleshoot. And when Tyler would sit down with Jason, who's a chemical engineer, and then we would have the every other day stand-ups, they would be able to help each other and bring other ideas to solve some of those problems. So in summary, a couple things about successes and some things that we're still learning and working on. Embedding people together, champions, experts with people that maybe haven't done it before, learn by doing. We pair them up. It's not just pair programming, it's pair scrumming, it's pair agile techniques. The agilistas, as we like to call them, the folks like Vrinda and now like Tyler, they are fantastic. And they will step up to a GE officer and say, this is how we work. And don't just experiment with the work that you have to do, experiment on how you do it.
Yeah, and there are some improvement opportunities, especially in this physical space. Agile is perceived to be a problem, and because we provide a lot of transparency, but it highlights all the dysfunctions in a traditional company of, the magnitude of GE and the size and.
We don't like to see problems.
So Agile is perceived to be a problem, and I think we have to celebrate the transparency that Agile provides, and it's our job to educate the executive leadership teams. And we can't consistently do that. And we had challenges with velocity policing, and that's something we have to battle against. But these are some things that you want to take back to your teams. Thank you.
You're getting the hook.
Yeah. All right.